Current situation is this virus is still endemic, and it has resulted, it's the parent, if you like, of the viruses you now have in North America. Vaccination has been highly variable in the Far East, and generally it's been unsuccessful. I'll briefly come back to that. And even in Europe and Africa now, in the last few months, we've seen re-emergence of H5N1. It had actually disappeared. Apart from Egypt, it had been absent from Africa for 6 years. And similarly in Europe, and yet it's reappeared. So we don't really quite understand why that is. So this is the map as of now. This is from the OIE, plotting outbreaks of HPAI, and you can see the big difference from what I showed you just now is this, which of course is what I'm now going to focus on because this is obviously very relevant to the Caribbean. So we've had quite unprecedented global spread, even on the scale that we're talking about for H5N1. So this virus has somehow now found its way into the Americas. So never before had that virus been found in the Americas. The important thing here to look at is the types of sector affected. So we've got different strains, H5N1, H5N2, H5N8. The one common thing about all those viruses is they have the same H. They have the same H number and they have got the same hemagglutinin. It's just that some of the other, the neuraminidase of different types, it's mixing. So it's being exposed to local strains. This H5N1 is not the same as the H5N1 in Asia. It has picked up an N1 from an American wild bird, which has recombined with an introduced virus to make something different. Not only that, it's being found in wild and captive birds. So some of the first reports up here were in wild and captive birds. But it's also been found in backyard poultry and in commercial poultry. So this outbreak down here in California was in commercial turkeys. And there's some outbreaks here in commercial birds. So this is not alone in America. This is what's happening in Europe. We only actually have two, H5N1 and H5N8. The H5N8 has been responsible for these outbreaks here. 4 European countries, mainly in the north. This might be weather related. But we've had a case down here in Italy and then recently in ducks in Hungary. So we have a problem with these viruses in Europe as well. And when they're in ducks, believe me, they're much more difficult to detect. Now, we can look at the characteristics. So this is the family tree and this is the genetic analysis we do. And we can now work out the time or the predicted time for introduction. So this is quite useful to understand how the virus is spreading. You know, the interesting feature is here in Europe, we think that the virus was most certainly present for several months before we saw disease and detected it in our surveillance system. What we do know from that analysis is wild birds is most definitely a key factor in spreading this virus around the globe. What we do know is because it replicates well in domestic ducks, that would indicate that it would probably also replicate very well in these birds. These chaps are everywhere in the world, gulls, and then there's the terrariforms. So we know that wild bird positive detection has been found with these viruses without any infection in poultry. And that's something we need to focus on for this region. Importantly, this virus is less pathogenic than H5N1 in ducks, which means it will be less pathogenic in waterfowl. H5N1 would often kill ducks, and there was always this statement, well, wild dead birds don't fly, okay? But this virus can infect wild birds, which might not stop them migrating. It might not interrupt their biological behaviour in the same way. So that's more dangerous, because the minute it crosses into chickens, it's highly pathogenic. We carried out the standard in vivo pathogenicity test. The maximum score is 3, which indicates all the birds die in 24 hours. We had a score of 2.88. So the minute that virus gets into chickens, highly lethal. The clinical presentation in ducks and geese, as I've said, is inapparent, and that's a challenge. And interestingly, and this is the case in the US as well, this virus is not just being, it's not being seen necessarily in outdoor production, it's being seen in indoor production. We don't fully understand why that is, but it may be something to do with the kinetics of the infection, but it does indicate that the virus is probably being deposited in the environment by wild birds, and then because of breaches in biosecurity, it's being mechanically moved into the indoor poultry units, A lot of birds, highly dense, very good breeding ground for the virus to spread rapidly. So that may be some clues. The other thing is that these viruses are extremely fastidious in the environment. We know, for example, that these viruses can survive at 4 degrees C for greater than 50 days and retain their infectivity. So what are the implications for surveillance? Clearly, perhaps this isn't relevant to your region, but we know that here asymptomatic infection in these birds is likely. Yes, it is highly pathogenic for chickens. That's good news because it means your passive surveillance in looking for clinical disease will work to detect these viruses. And of course, we need to make sure we've got the right tests. This is a newly evolved virus. Are all those tests out there fit? And that's the sort of work we do with others at reference laboratories to ensure that the tests, and we'll be liaising with Chris and others here to ensure that the tools that you're using in the Caribbean really do detect these viruses. So this is the postulated mode of spread, that this virus, this H5N8 virus, has been down here in China and Korea for 3 years now, and it's been maintained in their duck population and it's been in their wild birds. And what we think has happened is that that virus has gone through the wild birds back to the far north to the breeding grounds. Now what happens is when these wild birds in different flyways around the globe, they all go up here, and that's a smaller area than that. There's commingling, there's mixing between birds that live in different flyways, and we think that that's how the virus has spread, and then we see those populations migrating down different flyways, which has resulted in different introductions. So I think it's inevitable, maybe not in the next few months because of the seasonality, but probably it's inevitable that the virus is going to reach South America at some point. Now, if we look here at the flyways that are relevant to the Caribbean, and I think Emmanuel put a slide up showing this yesterday, we've got 4 major flyways in the US, and at the moment, the virus is probably present in 3 of those flyways. It's only the eastern one, which I know is probably the one most relevant to the Caribbean, that the virus hasn't been detected in. I think we have to work on the assumption it probably is in birds in the eastern flyway. Then if we look at some of the species and their distribution and range, again, it will be interesting to know whether some of these reach the Caribbean. I suspect some of them do, maybe not in large numbers, but may be sufficient for introduction of virus. The timing of that, of course, would be difficult to predict. Right now, the birds should start moving northwards. So it may be you have a window of time where the risk is a bit lower. But we don't fully understand all the factors. So I think we have to be cautious about too many strong statements. But the situation in North and Central and South America is changed. We know wild birds are a risk pathway. Therefore, we have to consider that the risk has probably to the Caribbean moderately increased. Probably we would have said it would have been negligible 3 months ago, or low to negligible. Now we have to say it's probably raised to low to moderate. We need to monitor the situation very closely in what is happening in North America. And I'll come to these poultry outbreaks in a minute because it gives us a clue that this virus isn't here for a very short period. I think it's going to be around for some time to come. That raises questions about your local surveillance systems, and been talking about contingency and awareness, and you've got the tools, you've got the framework, but are they being applied? How much do you need to apply them? I think there's proportionality needed there, not simply going out and finding every wild bird you can get your hands on and testing it. I'm not sure that's what you need to be doing. Then, of course, low path. So we've got notifiable here. Notice this N, low pathogenic notifiable avian influenza. H5 and H7, irrespective of their pathogenicity, should be reported to the OIE. And the reason for that is we want to control low path H5 and H7 before they mutate into highly pathogenic avian influenza. So that's why your colleagues in Belize, I guess, are not here, because they want to make sure they control that infection before it mutates into a virulent form, when it's a much bigger problem to deal with. I've already touched on the situation in Belize, and obviously at the moment I think they're assessing their options for control. And what I did pick up yesterday was they see they need to deal with this because it's a threat to their export market. Nobody wants to import birds from a country that's got low pathogenic avian influenza H5 or H7. Okay, so prevention and control. We need to define what the purpose of our control program is. I know that sounds obvious, but with H5N1 very often there is not a clear purpose or exit strategy. We need to take into account local factors. What's the risk of introduction? How is the virus going to spread? It doesn't necessarily spread here if it was introduced in the same way as it was spread in the Far East. What are the practicalities of the methods of control? We can't have a one-size-fits-all control program for avian influenza. And what's your desired result? And that is to actually prevent the virus entering the country, area, flock or farm in the first place. And that means that industry really have an incentive and a big responsibility to look at how their biosecurity is set up. And my recommendation particularly to the commercial, but all producers in the Caribbean, was to review their biosecurity. Are there things they can do? Are there small changes they can make that improve that biosecurity? And I think in terms of prevention, requires surveillance for early warning. For the Caribbean, we need a fit-for-purpose, achievable and realistic approach. It is not realistic to approach some intensive program that we might use in Europe, because we have to look at your local situation. So syndromic surveillance, Yvonne spoke about this yesterday, very important. I've mentioned increased mortality of more than 1 to 5% per day. In a chicken flock, you should be thinking about carrying out an investigation. You might see a reduction of egg production, more than 5 to 10%. Again, you should be thinking about, should we looking at differential diagnosis. More subtly, for the low pathogenic forms, which perhaps are of less concern to you at the moment, remember this reduction in feed and water intake. And then, of course, having got a suspicion, you need to carry out an inquiry on the farm and probably come to an agreement between the attending veterinarian and other specialists that perhaps you can't eliminate the risk that this is avian influenza or indeed Newcastle disease. So through the veterinary services, clinical samples are taken. We should remember that the signs are not pathognomic, so we cannot differentiate really reliably between HPAI and virulent Newcastle disease, and therefore they would need to be included in any differential diagnosis. Now that probably doesn't look like the Caribbean, but I'm sure you've got scenarios like that where you've got birds outside, and therefore your control, biosecurity is the key. You've got to think about all the movements, and I know there's discussion about trade and what you're bringing into the region and what are the risk pathways there. You've got to consider what's the probability of reporting within your poultry sector. What's the probability in the species we're talking about showing clinical signs? Well, I think if predominantly your production is chickens, that's good news because you should see clinical signs. And then where are your birds located? We've been travelling around the island, you've got a lot of birds here. Maybe not a lot of waterfowl, but you need to think about that. Then the wild bird, how do you do your surveillance in wild bird? Well, again, the approach we've taken in Europe is quite proportionate. We target certain species that we think are more likely to carry the virus. And I think if you're going to do wild bird surveillance here, rather than rushing off and doing a very large program that could be quite costly, which provides limited dividend, you need to be targeted. You need to think about what birds you want to sample and at what time of year perhaps, and do it in a more strategic way. And of course there are all sorts of things we can do around in the UK. We've been looking hard because we don't have resources to do extensive surveillance as much as we would like, so we have to focus it. So we're focusing on our free-range birds. We're looking at farms where there's water nearby. We're looking at farms where they have mixed poultry species. I don't know how common that is in the Caribbean, but that might be a slightly increased risk. So there are things you can do. Okay, outbreak response. So a control strategy, and there's a lot of similarities with what David said yesterday about foot and mouth. There's nothing weird and wonderful or different necessarily. Certainly you need early detection. Anything you can do that increases the chances of early detection is highly beneficial. It reduces that window of risk for spread where you do not know you've got infection present. You need to obviously restrict your suspected Any premise that's under suspicion should be restricted from moving birds until you've got the outcome of the laboratory investigation. And of course the infected premises, they need to be restricted. You need to, if you're going to go for a stamping out policy, and that depends what your legislation says, you need to slaughter infected and potentially dangerous contact flocks, not something we do a lot for flu. You need to decontaminate the infected region, farm. That can be a challenge, much greater challenge than slaughtering the birds usually. You need to impose movement controls if you're going for stamping out, because you've got to stop the risk for onward spread. And you've got to do good tracing and surveillance backwards and forwards to look for the source of the infection and to look for the risk of onward spread. Because remember what I said, that it won't necessarily be immediately obvious. You may have an incubation period of a few days. So you have to look at those tracing windows. And of course, public awareness is important, because the media will certainly have a feast. I can assure you of that. There'll be a lot of sensational lines. The minute you get a new introduction of something like this, not been seen in the Caribbean, you have to deal with the media as well. And of course, all of these are tenets of a normal stamping out policy, and you can impose control zones. And again, that will depend on what you have in your legislation and what tools you have at your disposal. Characteristically, we'd impose something of what we call a protection zone of around 3 kilometres and a surveillance zone of 10 kilometres. And then obviously you need to restrict movements, and you need to actually know where all your poultry are. That actually takes a lot of time, because I'm guessing you don't have a national poultry register here. So if you were to have an outbreak, you would have to find where all your poultry farms are. That's where, of course, good cooperation with the industry would be important, because it would be in their interest to work with you. Okay, laboratory diagnosis. So Keith mentioned yesterday the OIE terrestrial manual for diagnostic tests. That is obviously effectively the Bible of how we diagnose infection. And you know, there may be some, it may be a subset of the tools that are in there you use, and they should be reviewed annually. The chapter itself is subject to review every 4 years. And we need to know that all of the tests that we're using are properly, we know the test performance. We know their weaknesses and their strengths. They must be robustly validated. Now, the problem with AI is there are a lot of commercial kits on the market. The health warning is, or if you're going to use commercial kits, you need to check that they are properly validated in the context that you want to use them. And we have a diversity of viruses out there. Pen-side tests, David mentioned for foot and mouth, they haven't really taken off for flu. They generally lack specificity, and they certainly lack sensitivity, about a 10,000-fold. So they're not particularly a good route to go, I would say, right now. Much better, generally, if you've got laboratories within your island network and you can get samples to your laboratory relatively quickly, I think that's the route you should probably be looking at. So what do we take? The manual covers all types of scenarios, from freedom surveillance to what you do if you've got a suspicion. But if you've got a suspicion case, you would certainly like to have carcasses. So if you've got dead birds and it's HPAI, carcasses are going to be the best source of virus. But sometimes we have to be practical. I think 5 to 10 is probably a bit excessive. Providing these are freshly dead birds, coming back to Yvonne's talk yesterday, get the right sample type, you're going to increase your chances of a diagnosis. But oral pharyngeal and cloacal swabs and blood. So these should be a matched set of samples. So if you do sample, if it's a large commercial unit, go in, take 20 oral pharyngeal, 20 cloacal and 20 bloods, and you need to know how they match up. And that's important when you come to interpret your laboratory result, which will inform what stage of infection you have on your farm. Of course, if you're looking for source or spread, then you can go in with this standard sampling set, and you might modify it depending on the species you're looking at. And then for wild birds, well, what samples do you take there? These high-path viruses, whilst they can cause systemic infection, they are shed. The viruses that we have in North America at the moment, unlike their cousin H5N1, tend to have a very enteric tropism. Okay, in wild birds, that is. So cloacal swabs, would be probably better than oropharyngeal, but it's always advisable to take both. So just to stress, freshly dead or sacrificed birds. So if you've got a few moribund birds that are clearly an earlier stage of infection, it's sometimes useful to take those birds. And when you're taking necropsy tissues, well, the high path viruses do reach the brain. So it is worth taking the brain, but take that first, so it's not contaminated with these tissues. Trachea and lung can normally be batched together in testing, and then a range of systemic organs, heart, spleen, liver, kidney, all of these with high path will contain quite high quantities of virus. And then, of course, importantly, get them to the laboratory in the best condition possible. Now, you've obviously got environmental conditions here that we don't have to deal with in Europe, so they need to be chilled. I think there was a video yesterday that showed that all those principles apply. Get them to the lab quickly, chilled, so that we can get testing underway as soon as possible. Now, in a primary outbreak, you tend to do more testing than in a secondary spreading outbreak. PCR is the platform now. The advantage is you can get results in a few hours. But actually, if it was a primary, you'd probably want to do some of these other things. Now, it may be that this is where you have to enlist the support of OIE or FAO reference laboratories. And I know that the platform technology for PCR has been established here. And those PCR results can tell you what you've got as far as if it's H5 or H7. So, you know, that's a very good starting point. Now, in secondary outbreaks, you know, you may do a lot less. You wouldn't necessarily culture the virus if you had a fast-spreading outbreak. Obviously, in region here, you'd be focused on doing detection. Now, surveillance, you can use serology, but there's a big health warning here. For high-path avian influenza, chickens will die before they make an immune response. So don't waste your time doing lots of serology for high-path viruses in chickens. It won't tell you, assuming they're non-vaccinated, that is. It won't tell you an awful lot. And obviously we've been working with Chris through the project, and we can provide support as an OIE reference laboratory to do all of that in-depth characterization and analysis that you will need to inform your control effort. Now, this is a triage of how you go about confirmation. So you need to detect flu, and if you've got a positive, obviously you're going to then want to know what flu it is. So you start normally, there's two pathways, there's the classical and the molecular. Detection by PCR will tell us this is a generic gene in all flus, and it tells us you've got a flu. It doesn't tell you whether it's notifiable, but it tells you very quickly that you've got a flu there. Clearly, if you've got a clinical problem and you've got a flu A positive, there's a highly likelihood that it's going to be HPAI. You would want to culture the virus, but not all of those facilities are available in all labs. But if you follow the molecular pathway, you could then move to a PCR that is specific for H5 or H7. So it tells you whether those samples are not just flu positive, is it H5 or H7? Now, if it's not H5 or H7, you don't need to implement any control measures. It really is more an industry issue as to how they deal with that then, rather than through the veterinary services. If you've got H5 or H7 positive, you do need to know what is the pathogenicity of the virus. Now, you can make an assumption. If you've got a lot of chickens dying and you've got an H5 there, the likelihood is you can make a presumptive diagnosis of HPAI. But going back to the OIE definition, you'd need to enlist the support of a reference laboratory to determine the pathogenicity. And that can be done through sequencing, which is relatively rapid, or actually, in some cases, you can actually do the in vivo assessment. There are lots of additional technologies, and I'm not going to go through these, but there are all sorts of things we can do now. Thinking about One Health, colleagues on the public health side are going to say to you, well, you've got this virus, but what risk is it for public health? And we don't have a perfect understanding of which viruses can move into humans and which can't. But we do understand some of the genetic features on the virus that increase the risk for public health. So inevitably, if you had a virus and it went into a reference laboratory, one thing they would be doing is they would be assessing the potential risks of public health of those viruses and making sure that information is available in a timely way. The people that are involved in the control effort will need to take proper protection, preventative measures for exposure to virus. There have been incidents in outbreaks around the world where people involved in culling or the control effort have been exposed to high viral load and have become infected. So there's a very strong awareness of this now. In fact, in the UK, it takes us longer to get the people prepared to go and do the culling and have their antiviral drugs than actually go and do the culling effort. It delays the culling operation. So vaccination, okay, the desired results of AI vaccination would be freedom from disease, of course. You wouldn't have any adverse effect on production. You wouldn't want to suffer trade embargoes. If you're a trading nation, you wouldn't want it to compromise that. And of course, hopefully, it might help you eradicate infection. Current vaccines generally will protect against clinical signs, they'll reduce virus excretion, and they'll increase the dose needed to infect a bird. But you've got to remember, virus will still replicate in vaccinated birds, so it's still a risk. And it may be more difficult to detect in a vaccinated population. And this is part of the problem that's been encountered in Asia, in that sometimes vaccination has been used as a tool alone. Countries that have used vaccination in combination with culling of infected flocks have had greater success in control. There's all sorts of other things about the delivery of vaccines. We don't have the same vaccines that we have for Newcastle disease. We don't have live attenuated vaccines because obviously live attenuated vaccines may revert to virulence. In the same way as we're talking about FMDSD, next generation vaccines are coming on stream. So I would think in the next 5 years we do have much better, more potent vaccines that we can apply a DIVA strategy to. But at this moment we don't have them. If we look at successful use of vaccination, it has been applied with some limited success against low path. I would stress low path. But if we look at unsuccessful use, Mexico for a long time grappled with H5N2, started off with low path, mutated to high path, took them a long time to get rid of that, even though they used extensive vaccination. And the clue probably is a lack of surveillance in your vaccinated population. There's actually quite a big effort when you vaccinate to monitor what's going on. It's not an easy win. And of course, we've got, unfortunately, a number of countries in the Far East and in Egypt where you probably see they have a lot of human cases at the minute. They've been vaccinating, it's been applied in an inconsistent way, and the quality of the vaccines is highly uncertain. So to conclude on AI, there's a wide range of viruses in wild birds. There are new global events occurring. We are dealing with an H5 panzootic, there's no question. And we've got recent unprecedented global spread, which raises questions for preparedness. Yes, these viruses, low path, do occur regularly in the poultry sector. If you look, you do find them. We find quite a lot in Europe when we do a lot of surveillance. We've got viruses emerging out of the Far East, and I haven't even talked about the other subtypes that actually can have quite a big problem on production. H6, H9, if you get that in a chicken flock, that will have the same impact as a low path H5 or H7, so it could affect economic viability of production. So I think, to conclude really, it's all a bit doom, I know, but significant threat to future global food security and pandemic cannot be overlooked.